Welcome to Enzyme Safety Module 4, where we will cover enzyme monitoring. This module is the fourth of 5 modules as part of the IFF Enzyme Safety Training Program. We encourage you to view each module consecutively. There are 5 learning objectives covered in this module. 1. To review the established occupational exposure limits for enzyme safety. 2. To understand the purpose of enzyme monitoring and how to develop an air monitoring strategy. 3. Understand how to develop an air sampling plan. 4. Learn about the types of air monitoring equipment used for enzyme sampling. And 5. To identify the key elements for data analysis and key decision-making. Enzyme air monitoring is conducted to measure potential exposures and to assess the effectiveness of engineering controls. The monitoring strategy represents the check and act components of the continuous improvement process. Some companies have internal staff who can conduct air monitoring activities, while other companies choose to hire outside consultants. The components of an air monitoring program include the purpose of monitoring, regulatory limits, air sampling plan, air sampling equipment, data analysis, employee feedback, and corrective actions and follow-up. The American Conference of Governmental Industrial Hygienists, or ACGIH, established occupational exposure limits for all enzymes, set at 60 nanogram per cubic meter. These levels were adopted as regulatory standards by multiple countries. The European Union adopted 60 nanogram per cubic meter as the derived minimal effect level for worker exposures and 15 nanogram per cubic meter for consumer exposures. Some countries have adopted different limits, so it is important to know the regulated safe limits associated with the region of operation. A qualitative evaluation or risk assessment should be conducted before enzyme sampling. Examples of key objectives include measure worker exposures, prevent health effects, verify controls, and evaluate consumer safety to determine if enzyme exposures are within acceptable limits based on the application. Air monitoring plans are prioritized based on the suspected risk of exposure to workers. A qualitative evaluation or risk assessment be conducted before enzyme sampling. Generally, this evaluation involves familiarization with process and tasks, understanding the controls, and observing the operation. Once the workplace assessment has been completed, an air sampling plan can be designed for personal and area sample collection. There are 3 general sampling approaches that can be used to help understand the sources of potential exposures. Point source samples are taken at the point of operation where there is higher potential for peak exposures. These types of samples are generally taken during tasks that involve manual material transfers, such as enzyme sampling ports or during enzyme dosing and mixing. Area samples taken in the general work zone can help provide data to assess the overall effectiveness of controls. Finally, personal samples are placed near the worker breathing zone and are used to monitor personal exposures. This data can be used to help select appropriate respirators and understand if the worker is being exposed to levels above the occupational exposure limit set at 60 nanogram per cubic meter. High volume and low volume pumps are used for enzyme air monitoring. The choice between the pump depends on the purpose of the air monitoring. High-volume sampling is used to detect peak enzyme exposures associated with higher potential exposures, such as open material transfers like pouring. Low-volume samples are used for personal sampling to understand enzyme exposure over a set period of time, as determined by the risk assessment. Data collected from the sampling event are compared to the established occupational exposure limits. The results help to establish corrective actions that may be needed to minimize the exposure potential and protect workers from being sensitized. The samples, along with the volumes of air collected, must be submitted for evaluation by a qualified laboratory. The results are used in the following ways. 1. Results that are above the occupational exposure limit of 60 nanogram per cubic meter will require immediate corrective action. 2. The results from peak exposure monitoring can help to identify the source of enzyme exposures and can inform the control strategies used to reduce the levels within exposure limits. 3. The data from area samples, peak exposures, and personal samples should be used when developing your risk management strategy. And 4. Follow-up monitoring is needed after control measures have been implemented to validate that the enzyme levels have been appropriately controlled. Feedback and corrective actions are the final part of your air monitoring activity. It is important to note that a corrective action plan should be implemented immediately following results that show levels above the enzyme occupational level. The corrective action plan should be communicated to all affected workers so that the changes are properly instituted. At the conclusion of a sampling event, a summary report should be completed, and the results should be shared. Generally, the report should include the following: the objectives and purpose of the air monitoring sample, the sampling protocol and methods, the equipment information, the results, a discussion, and a list of the recommended corrective action plans. As a recap, we discussed occupational exposure limits for enzyme safety is 60 nanogram per cubic meter. We also went over air monitoring protocols to understand areas of high exposure potential and to reduce the risk of sensitization through control measures. We discussed the specifics of an air sampling plan, starting with a qualitative assessment to help set up the sampling strategy. We learned about the types of air monitoring equipment used for enzyme sampling and the criteria for selection. Finally, we identified the key elements of data analysis and the importance of a final sampling report to communicate results to workers and implement immediate corrective actions and appropriate risk management strategies. This concludes the presentation for Module 4. What's next? Module 5 highlights medical surveillance programs, which can be implemented to monitor worker health effects.